Okay, so now that we've factored binomials as the difference of squares, now we can go on to perfect cubes. Okay, so a cubed minus b cubed can be factored, and a cubed plus b cubed, be careful, it's not prime, right? It's only a squared plus b squared. That's prime. But a cubed plus b cubed can be factored. And I'll just show you how to do it, right? So a cubed minus b cubed is going to be a minus b. That's the easy part. The hard part, right, the next factor is actually a trinomial. It's a squared plus ab plus b squared. So what about a cubed plus b cubed? It's not prime. It's a plus b times a squared minus ab plus b squared. Okay. So I will grant you that these are not going to be quite as simple to remember, but you do have to know these because we're going to use these over and over again. Okay. Before we go on, maybe we should review the cubes. So 1 is a perfect cube because it's, 1 times 1 times 1. 8 is a perfect cube. It's 2 times 2 times 2, 2 to the 3. 27 is 3 to the 3. 64, well, that's a perfect square, right? It's 8 squared, but it's also 4 cubed. So yeah, be careful about 64. It can be a perfect square or a perfect cube. The next one is 125, which is 5 cubed, right? And then 216 is 6 cubed. And then 343 is 7 cubed, and so on. 512 is 8 cubed, and I think we'll leave it at that. Right. I mean, you can always check by taking the cube root of these. If I take the cube root of 512, you can check you get 8. So if you take the cube root of a number and you get a decimal, you know it's not a perfect cube. Okay? All right. So let's start with the easiest example I can think of, x cubed minus 8. How do we factor that? Okay, well, first of all, GCF is 1. Don't forget that. That applies here as well. And this is going to be a perfect cube. It's x to the power 3 minus 8, right? 8 is 2 to the power 3. Okay, so this looks an awful lot like a cubed minus b cubed, where a is just x and b is just 2. So if a cubed minus b cubed is a minus b times a squared plus ab plus b squared, then x cubed minus 2 cubed is just x minus 2 times x squared plus x times 2, although we usually put the 2 in front, right? So that's just the same as 2 times x, plus 2 squared, but 2 squared is also 4. Okay, so that's it. Right. So we can factor x cubed minus 8, just to make it abundantly clear. It's x minus 2 times x squared plus 2x plus 4. And that's it. Okay. So a couple of issues here. First issue is, are we sure that this is right? Right? Maybe we should check. And how do we check? We have to multiply this out here, right? And this is not an easy multiply because, well, it's not FOIL because there's 3 terms here. It's not just 2. So here's how I would do it. I would take the x first and multiply by the entire trinomial, and then the negative 2 also times the entire second trinomial. Okay, so now you're just distributing, right? X times x squared is x cubed. X times 2x is 2x squared. And x times 4 is 4x. Okay, so far so good, right? We're halfway done. Now the negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. And then negative 2 times 4 is just negative 8. All right. Well, there's a lot of simplifying to do here. Notice that 2x squared minus 2x squared is 0. So they just cancel. Likewise, 4x minus 4x is also 0. So they cancel. So what are we left with? Well, we still have x cubed, and at the very end here we have the minus 8. But that's what we started with, so we know that this is correct. Or, yeah, before I messed it up with those things there. Okay, that's a little better. All right, so we checked it. We know it works, right? So that's the correct answer here. X minus 2 times x squared plus 2x plus 4. All right. Second issue is, notice that this factor here is a trinomial, right? It's 3 terms. So we have x squared plus 2x plus 4. Right. How do I know that that can't be factored any further? Maybe we should try to factor it, right? Well, let's see. This is just 1x squared, so I'm going to use the shortcut. Now, what two numbers multiply to 4 and add to 2? Well, what two numbers multiply to 4? I can do 1 times 4, but 1 plus 4 is 5. So this doesn't work. Right? We have the x squared and the 4 correct, but the middle term does not match. The middle term is 5x. We're looking for 2x, right? Okay. Well, there's one other way to do this. 4 is also 2 times 2. So I can do x plus 2 times x plus 2. Right? In fact, that's a perfect square. You get x squared plus 4x plus 4. But again, we have the same issue. The 4x does not match the 2x here. Right. And I think those are the only two possibilities here. Since we've exhausted all the possibilities, we know that this is prime. We cannot factor it any further. Okay, so as it turns out, this trinomial here, the x squared plus 2x plus 4, is prime. And we can tell you that right now, these trinomials here, both of these, are always going to be prime. Again, the caveat is for our purposes. In this class, these will always be prime. And if they are factorable, we're not going to hold you to it, right? So it turns out that these trinomials can sometimes be factored, but we're not going to bother with that, so don't worry about it. In fact, I apologize I even told you about that, right? For our purposes, these will always be prime. So the good news is that when you do the perfect cube, and I grant you that this is not easy, it takes getting used to, but the good news is this, that this trinomial here, you can always stop. You don't have to try to factor this any further. It will always be prime. Right. It doesn't hurt to check, right? In fact, I did that here, and it was a little bit of work, but I tried both possibilities, and none of them worked, right? None of them matched the middle term, the 2x. So that's how I knew it was prime for sure. But now you know that you don't even have to bother checking these trinomials here. As long as it's part of the difference or sum of cubes, if it's one of these two formulas, you don't have to bother checking the trinomials. They will be prime. Okay. Now, the binomials may or may not be prime. You should check those. Right? In this case, x minus 2 is certainly prime. Right? There's no way to factor that any further. But I can't always guarantee that that will always be the case, especially with the a minus b, right? Because that could also be, say, a squared minus b squared. You know, it's a possibility. Right? All right, let's do another one. Okay, so here we want to factor x cubed plus 125 y cubed. Okay, so first thing to note is that they're both perfect cubes, right? And that this is a sum, not a difference. So the formula we're probably going to be using here is a cubed plus b cubed. And just to remind you, it's a plus b times a squared minus ab plus b squared. My suggestion is, if you didn't remember that, then write it down, because this is what we're going to be using here, right? And we should have written it down up here as well. In fact, I did right here. Right? All right. Now we just have to figure out what is a and what is b here, right? And it should be pretty clear that a is really just x, because it's x cubed or a cubed. Same thing, a is x. Now the b here is a little trickier. 125, here it is. 125 is a perfect cube, right? It's 5 cubed, 5 times 5 times 5. So this is going to be 5 times y cubed, right? So I did skip this step here. This is 5 cubed times y cubed, but that's the same as 5y cubed. Okay, so that tells me, again, a is x and b is 5 times y. Now I just fill in the blanks here, right? A is x and b is 5y. So a plus b is just x plus 5y. But notice, now we have to be a little more careful. What is a squared? Well, a is x, so a squared has to be x squared. No problem there, right? Minus a times b. So what's a times b? A times b is x times 5y. Or better yet, bring the 5 in front. It's 5 times xy. Right? And then plus b squared. So what's b squared? Well, it's 5y squared. Right? Or if you like, 5y times 5y. 5 times 5 is 25. Y times y is y squared. So b squared is 25 y squared. Right. If you can't work that out in your head, work it out on pencil and paper like I did here. Right. And that's it. We're done. And again, we know we're done because remember, this trinomial here, even though it looks like, well, maybe it's factorable, right? It's not. We know that this is prime here. And x plus 5y is certainly prime, which means this is the final answer. This is as far as we can go. Okay, so just to summarize, we factored x cubed plus 125 y cubed as x plus 5y times x squared minus 5xy plus 25y squared. And if you don't believe me, check, right? Just multiply this out term by term, and what you should end up with is this, right, on the left. So this time I'll leave it to you, right? I did check the last one. I checked that over here in blue. So it's always a good idea to check if you're not sure it's right. All right, try another. Okay, factor 2r cubed minus 128. Yeah, see if you can do that, right? This is not an easy one, right? And if you don't recognize the 2 and the 128 as perfect cubes, it's because they're not. However, the GCF is 2, so I have to factor out the 2 first. Now this should look a little more familiar, right? The 64 way up here is a perfect cube, right? It's 4 cubed. All right, so just so that we know, we're going to factor this because it's a minus as a cubed minus b cubed. So write it down again. It's a minus b times a squared plus ab plus b squared. Right. So again, don't get confused with the sum, a cubed plus b cubed, which is a plus b times a squared minus ab plus b squared. Right. So if the issue is where the negative sign goes, here's something that some people find helpful. SOAP. How is SOAP helpful here? So in this case, SOAP stands for same, right? Opposite, always positive. Okay, yep, same, opposite, always positive. So what do I mean by that? Well, here we have a minus sign for the first one, right? A cubed minus b cubed. The first sign here will be the same. It'll be a negative sign, right? Then the next sign will be opposite of that. The opposite of negative is positive, right? So this one's the same, right? And then this one's the opposite of that. And then the last one is always positive, right? It doesn't matter which one we have here. This will always be positive. So, yep, you can see that, right? For the a cubed plus b cubed, the first sign here is the same. It's a plus. The second one is the opposite. The opposite of plus is minus. And then the last one is always positive. Okay, so if you find that helpful, great. Otherwise, just make sure you know which is which, right? Okay, so back to the problem here. R cubed minus 64, right? We're not done with that yet. We can keep going. Right? So here a is just going to be r, and b is going to be 4. Right? And we know that because 64 is 4 to the 3. Right? You want to be careful because you don't want to write it as 8 to the 2. The problem with that is that these exponents don't even match. So that's not going to help at all. You want the exponents to match. Now they're both 3's, right? Okay, so a is r, b is 4. So this is going to be 2 times, well, a minus b is r minus 4. Right? And then a squared plus ab plus b squared. So a squared, of course, is just r squared plus ab. So a times b, oops, I'll do that over here, is r times 4. But that's also just 4 times r. So I'll put the 4 in front, 4 times r, right? And then always positive, right? So plus b squared. Well, b squared is 4 squared, and 4 squared, 4 times 4 is 16. And there we go. I think we're done. Okay, how do we know we're done, right? So 2 is prime. Can't do anything with that. R minus 4. Now, 4 is 2 squared. It's a perfect square. But the r is not. Right? It's not r squared minus 4. If it were, you can go further, right? You can do r minus 2 times r plus 2. But it's only r minus 4, not r squared minus 4. So that tells me that r minus 4 is prime. We're done with that. And the trinomial here, the three terms, r squared plus 4r plus 16, looks tempting, right? Looks like you can go further here. But no matter what you try, right, 16 is 8 times 2. That's not going to work, right? Or 4 times 4, or 16 times 1. It's not going to work, right? It's going to be prime. Right? So the trinomial will always be prime. I think I mentioned that way up here. Yep. These trinomials, the three terms, will always be prime. Okay. So that's it, right? So that's as far as we can go here. I'll leave it boxed because that is our answer for this problem. So yes, GCF comes first. Again, usually it's 1. In this problem, it was not 1. So we had to factor that out first, and then proceed with the difference of cubes here. Got it? Try another one. Okay. We want to factor 27a cubed plus 8b cubed. Got it? Right. So again, a little bit tricky here because capital A and little a are not the same thing. Oops. So we're going to be using a cubed plus b cubed. So using SOAP, this is a plus b. And then opposite, so a squared minus ab. And then always positive, b squared, right? Okay, so now we just have to figure out what is capital A and what is capital B. Well, so 27 is 3 times 3 times 3. It's 3 cubed, right? And 8 is 2 times 2 times 2. It's 2 cubed. So this is 3 times little a to the power 3 plus 2 times little b to the power 3. Okay, so by doing that, we should be able to identify capital A is really just 3 times little a. And capital B is just 2 times little b. Okay. Right. Now we can write out the factoring here. Right? A plus b is 3a plus 2b. Or if that's confusing, capital A plus b, right, is 3 times little a plus 2 times little b. Okay. Now comes the hard part, right? The trinomial. A squared. What is a squared? Well, it's 3 times a squared, which is 9a squared. Right? Minus ab. So a times b is 3 times little a times 2 times little b. And 3 times 2 is 6 times little a times little b. So capital AB is capital AB is 6 times little a times little b plus b squared. So b squared is 2b squared. 2b times 2b is 4b squared. So capital B squared is 4 times little b squared. And remember, this trinomial here is complete. It is factored completely. It is done. It is prime. So that means this is our answer. So I should probably use green because it is correct. Okay. So this is a pretty standard one. You just kind of have to get used to it, right? I know it's not easy at first. I'll let you try another and see how you can do. Okay, so try this one. We want to factor 8x cubed minus 64y cubed. Okay, so I hope you factored out the GCF, which is 8. Factor out the 8 first. Right. And you get 8 times x cubed minus 8y cubed. so that should be a little bit easier here. Right? Because 8 is a perfect cube. It's 2 cubed, right? So that tells me my capital A is little x, and my capital B is 2 times little y. Now we're always using lowercase x and y, so I'll just say B is 2y, A is x, right? And hopefully you wrote down, oops, that's a cube now. A cubed minus B cubed is A minus B times A squared plus AB plus B squared. Yeah, make sure you know that. So now we're just going to apply that here. So A minus B is x minus 2y. A squared is x squared. A times B, well, it's x times 2y, or 2 times x times y, right? So just 2xy. And then plus b squared, well, b squared is, right, 2y squared. So 2y times 2y, oops, so 4y squared. Okay. Oh, I forgot something. I forgot the GCF, right? Don't forget the 8 in front, because that is part of the answer. All right, that's how it goes. Let's keep going. Let's do one more. All righty, 40x to the 5 plus 135x squared. Go ahead and try that. And you should use the previous problem as a guide. The GCF here is not 1. Right? I mean, what should tip that off is the fact that, right, these aren't cubes. There's no power of 3 here. So that means we should at least be able to factor out an x squared. But what about the 40 and the 135? So 40 is 8 times 5, and 135 divided by 5 is 27. So 27 times 5. So they both have a 5 in common here. So the GCF is 5x squared. So take out the 5x squared, leaving you with 8x cubed plus 27. Got it? Right, so that's, right, I mean, I'd say that's the hard part, but that really is the easiest part. Now you still have to factor this, right? But if you notice, it's very similar to the last one, this one up here, number 4. Right, I just changed the 8 and 27 around, and it's pretty similar to that, right? So again, keep the 5x squared. This is going to be 2x to the power 3 plus 3 to the power 3. Right? So my a here is 2x and my b is 3. And this is a sum now, so we're going to factor a cubed plus b cubed as a plus b times a squared minus ab plus b squared. Right? So keep the 5x squared. So the a plus b is just going to be 2x plus 3. And now the a squared is going to be 2x times 2x, so 4x squared, minus ab, so 2x times 3 is 6x, plus b squared, 3 squared, 3 times 3 is just 9. And that looks to be about it. Got it? So, yep, don't forget the GCF first. Once you do the GCF, look for sum and difference of cubes. Okay? Try this one. Okay, so try 8p to the 5 minus 50p to the 3. Right, 8p to the power 5 minus 50p cubed. Got it? All right, well, let's see how you did. Right, GCF is not 1. I think it's just 2. P to the 3. Right, so we'll factor out 2p cubed, leaving you with 4p squared minus 25. I think that's it, right? So that's the GCF. And now we just have to factor what's in the parentheses, the 4p squared minus 25. Right. So kind of a trick question here because this is not perfect cubes at all. Right? This is going back to a squared minus b squared, which is the easy one, a minus b times a plus b. Right? So here a is just 2p and b is 5. Well, let's write it that way, right? This is 2 times p squared minus 5 squared. No cubes here, right? Well, there's this cube, but that's, that's in the GCF. There's nothing else to do with that. Okay, so 2p cubed times a minus b is 2p minus 5, and then a plus b is 2p plus 5. And so that's it. Okay, so I'm kind of leading you a little bit astray here. This has nothing to do with what we've been doing. This is not some indifference of cubes here. Okay, so hopefully this was an easier one. If you weren't trying to find a difference of cubes or a sum of cubes. Right. So yeah, and we'll do some more sort of odd factoring problems that go back to, other methods like trinomials or factoring by grouping. Okay. All right, so back to perfect cubes. Oops. All right, so I got to clear all this. Okay, 27x to the 9 minus 343. Right, and this really is a difference of perfect cubes. Got it? All right. So 27 is 3 times 3 times 3. And x to the 9 is x to the 3 to the 3. Right? So this is really 3x cubed all raised to the third power. Okay, so that tells me what a is, right? A is just 3x cubed. What about b? So 343. If that does not look familiar, right, take the cube root of 343, and that should give you 7. So reverse it, it's 7 to the 3 is 343. So it is a perfect cube, but it's one that you probably are not going to memorize. 7 cubed, right? So that tells me that b is 7. Okay. Yep, just making sure. All right, so now we have our a cubed minus b cubed. Here it is again. A minus b, a squared plus ab plus b squared. Again, if you write this down every time, and you're going to do, I don't know, maybe a dozen of these, hopefully that's enough. It'll kind of stick. Yeah, I don't know. I mean, I must have done hundreds of these, and writing this down every time, you're going to remember it eventually. I don't think it'll take 100 times to remember it, but it's maybe a dozen or so. All right, so that's how I memorized it. If there's another way that you can remember it, some mnemonic device that I'm not aware of, good enough, right? As long as you know it. So yeah, the hard part, once you memorize this, the hard part is actually in applying it, of course, right? So this is going to be, again, a cubed minus b cubed. And so in this case, a is the 3x cubed, right? Minus b is just 7. Okay, so second factor, a squared. What is a squared here? So if it's not obvious, let's write it out. It's 3x cubed squared, right? So it's essentially 3x cubed times 3x cubed. So 3 times 3 is 9, and x cubed times x cubed is x to the 6. Yeah, I hope you didn't do x to the 9, right? Remember, you add the exponents. 3 plus 3 is 6. So a squared is really 9x to the 6. Not 9x to the 9. All right, plus a times b. So a times b is 3 times x cubed times 7. But 3 times 7 is 21, so it's just 21x cubed. 3 there. Plus b squared. Well, b is just 7, right? So 7 squared, 7 times 7 is just 49. And I think we're done. Okay, so, yep, you can check, multiply it out if you want, but 27x to the 9 minus 343 is 3x cubed minus 7 times 9x to the 6 plus 21x cubed plus 49. Right. Yeah, we skipped it, but GCF is 1, so we didn't have to bother with that, right? All right. Try one more, and then I think that might be it. Okay, factor h to the 6 minus 1. Right, so this one's deceptively simple. It looks easy, but here's the key, right? You're looking for the, right, so the GCF is 1. I think that should be obvious, right? And h to the 6, we're looking for a perfect cube, right? So what times 3 is 6? 6 divided by 3 is 2. So h squared cubed minus, well, 1 times 1 times 1 is also 1. So 1 cubed. Okay, so that tells me that my a should be h squared, and my b is, well, just 1. And we're going to factor this yet again as a cubed minus b cubed, which yet again is a minus b times a squared plus ab plus b squared. Got it? All right, so let's start with a minus b is just h squared minus 1 times a squared. Well, a squared is h squared squared, so h to the 4. And then a times b is just 1 times h squared. And b squared is 1 squared. 1 times 1 is still 1, right? So you end up with h squared minus 1 times h to the 4th plus h squared plus 1. And if that's as far as you got, well, okay, you're about halfway done. So you'll get half credit or so. But it's not factored completely. Right? This you should recognize as my usual a squared minus b squared, right? So a is h and b is 1. And a squared minus b squared, not to be confused with a cubed minus b cubed. Right? A squared minus b squared is just a minus b times a plus b. So in this case, I'll keep it in yellow here. Yep, so h squared minus 1 is just h minus 1 times h plus 1. Okay. Now, what about the h to the fourth plus h squared plus 1? Can we factor that? No, I don't think so. So that's prime. Remember, the trinomial here, this part here is always going to be prime, at least for our purposes. There are some situations where this could be factorable, but I don't think this is one of them. I could be wrong, but it doesn't matter, right? The thing that you did have to factor, of course, is this h squared minus 1, which is just the difference of two squares, a squared minus b squared. So don't forget that. We did one like that pretty recently. We did a bunch of them in the previous video, so don't forget that. All right, one more, and then we're done. Okay, last one. We want to factor 125 u to the 3 minus 1000 w to the 3. And you shouldn't really see numbers quite that big. But, you know, it could happen. You never know when it will show up in the homework. So, yep, I hope you did the GCF. In fact, it is just 125, right? Because 125 times 8 is 1000. So you factor out the 125, leaving you with u to the power 3 minus, oh, I should have done a plus. Too late now, right? You've done it already. Minus 8w cubed. Yeah, I realized the last several that we did were all minus signs, and of course, you should also remember the one with the plus. So, all right, it's fair enough. All right, so now that we've done that, you should recognize this as a cubed minus b cubed, where a is just u and b is 2w. Right? So a minus b, u minus 2w. Right? And then a squared, u squared, plus ab is 2uw, and then plus b squared is 4w squared. And we're good. All right, so again, I regret not doing enough plus signs here. I know we did some, but maybe not enough. All right, well, I did say that was it, but we have time. Let's do one more. This time it'll be with a plus. And kind of running out of examples here. All right. How about this one? 54x to the 4 plus 16x. All right. Well, GCF, I think it's just 2x. So factor out the 2x, and you're going to be left with 27x cubed plus 8. Okay, and then we did one like this earlier. So again, the hard part was just making sure you do the GCF first. Otherwise, I don't think there's anything else you can do, right? And now we have a sum of cubes, right? 3x to the power 3 plus 2 to the power 3. So a is just 3x, and b is 2. And I know we've seen things like this many, many times, right? Otherwise, the numbers just get really crazy here, right? So this is a little different, right? This is a cubed plus b cubed, which remember is a plus b times a squared minus ab plus b squared. Okay. So a plus b is 3x plus 2, And then a squared is 9x squared minus ab, 6x, plus b squared, which is just 4. So I think if you can handle this, you should be fine. Right. So again, it takes getting used to. But if you manage to do these, the homework shouldn't be that much harder. In fact, in most cases, it should be a little bit easier. But we've certainly done some more difficult ones, like these ones with big numbers and ones where you had to do the difference of squares afterwards and so on. So I hope that's enough. Best of luck.